Hi, I'm Tom. I talk about code. Welcome to another Rust live stream where today we're doing even more work on my compiler. It's another stream where we're doing structs. We're almost at the end with structs. We're going to try today to check off nested structs. That would be really, really cool. And honestly, this might just work out the box. I suspect there are a few rough edges, but if I've done everything properly up to this point, nested structs will just work. So we're going to start by writing some test cases and then go back as we find what is broken. Then we're going to add size of, which is going to be quite important if we want to start doing more memory management-y things. And then we want to maybe also write some kind of offset of. It would also be cool if we could get the type of something as a value in the programming language. I don't know if that's something we can really do. I don't know if that's really practical, but that's a fun idea that just came into my brain. So we can think about that. I'll let that simmer while I do the stream. Actually, what would also probably be good as an extra goal would be clean up, that's, excuse my handwriting, struct field assign. For example, if we say foo.bar.x equals 5. Currently the way I parse and do with this is, well, the code gen especially is very, very jank. I fixed it for the right hand side. We need to backport that over to the left hand side. So this is a good little checklist. This is going to be good. I've got a pot of soup cooking, so as soon as that soup is ready, I'm out. It's dinner time. So it's a race. How much of this stuff can I get done while my soup is on the pot? I'll jump over to the correct scene. I'm gonna be on the correct scene every single time today. I'm not gonna get it wrong at all. Right? So we're gonna nail it. We're gonna nail it. What am I? Home scripts. Cool. So we're just gonna start recording. We're gonna not press Control D. So let's jump in and let's start by writing a test for nested structs. Now, I should be able to make a value. I should be able to make a struct value, which is cool. We'll do this kind of thing we were doing before. We have a struct foo. We're gonna have a struct bar. This is gonna have the field x. Foo is gonna have a field called bar. And these were kind of the examples I was looking at before, right? We'll clean up all this extra crap. And we can forward declare a local. We can say let foo. We can make a variable called foo that is of type foo. We can't initialize it to anything, but this makes sure that there's space in the stack frame for a foo. So we could say foo.bar.x equals 5, and then return foo.bar.x. And we would expect that this would be 5. Does this work? I need to rename the function. Struct nested fields. Of course it builds. Does it test? No. Not only does it not pass, it doesn't parse. It fails not where I expected it to fail. What is going on here? Type foo, type bar. Yes, I use commas, not semicolons, because I've been corrupted by C. Okay, now it blows up. This time it blows up in the compiler. Does it? Yeah, this is the compiler. Unwrap on an error value. Yeah, so what's the error? Cannot assign from int to struct. So what it's saying is when we try and do this assignment, it's trying to assign this to the entire struct bar. And of course it is, because if I go and look at the code gen for assign deref, assign struct field, I get the first thing and I get the second thing. So all I'm actually looking at here is foo.bar. That makes sense. That makes a lot of sense. Okay. So actually, I'm glad I wrote this extra thing down. I was like, oh yeah, here's just a little extra thing I might do. Turns out this has to come. Well, this should probably come first. This probably needs to be start here first. Let's say first. Cool. Okay, well that was good. That was good. That was a good way to start everything off. Let's do it. Let's do this. And let's write a test that tests for just this first as well. Let's write a simpler test where we just have a foo. Foo has a field called... Let's put two fields in there because it's more interesting with two fields. Actually, no, but it needs to be nested, doesn't it? Actually, this is a fine test. This is... I don't know why I'm copying and pasting. This is a good test for this. Okay, so this is going to be really similar to generating the code for the expression. The idea is going to be the same. Foo, that's not what I meant to do. Foo is a struct. So to get field bar in foo, we add the offset of the field. Then we keep going. To get the field x, we add the offset of the field x in bar. We keep adding this as kind of like a sum. The complication is if any of these are pointers. If any of these are pointers, we suddenly have to generate code and do that at runtime. It's no longer adequate to do it at compile time. So one thought I have for approaching this right now is to pretend that pointers don't exist. Just sum it up, assume they're all values, and get that working as a starting point. That might be too simplistic, but it doesn't feel awful. It doesn't feel awful. It doesn't feel too bad. The other approach is to do it all at runtime. Even if we could calculate the complete offset up front, do as much of it... Well, actually, we can do a hybrid. So we're gonna need... we'll need a variable called working offset, okay? And this is gonna start at 0. As we find struct values, we will accumulate offsets into this value. Okay, so the first value that this should be is whatever the first field is. So fields first. First off, if fields dot is empty, if there's nothing in this, then we need to return an error. And that error is going to be a new type of error. We're going to need, and it's going to be struct. Actually, you know what? I think we can panic here for now. I think we're just going to panic. Because we should never get here. If we reach this code, then our parser has failed us. Okay? And this is actually one of these funny places. I think some languages actually have an abstraction of a list with at least one element in it. I think Idris has a type like that. Like languages like Idris and Ada with very, very powerful type systems, they give you that power. Rust, I mean, we could build one, but that's not worth doing. We're going to stick using a standard vec, which means that we have this possibility that even though from a kind of static assertion type level, we're confident that this thing is not empty, we still need to assert that it's not empty. Okay. So, here's the plan. We have a working offset. We will call this WO. Let's say WO, and we'll say it equals, let's say it equals address of X. In other words, the memory address of our struct. The thing that we're gonna reach into computer memory and take from. The box in computer memory will take from. If this is a value, this will point to... if X is a struct value, if it's declared like in our test, then the address of foo will point to the stack frame. If it's a pointer, it could point anywhere in memory. Anywhere at all. So we get this starting reference, and then as we step through each field, for each field yeah, okay, we're gonna blend some code styles here. It's okay. So for each field, what do we want to do? If field, if I don't know how to really express this. If let's just assume we can say like get the type of X and then get a field, and this will like somehow blow up if X isn't a struct. Except we need to like store this somewhere. God, pseudocode can be hard sometimes, can't it? Get rid of this. Let's have a big old arrays here. So let's say t equals this. If t is a pointer, we need an offset as well. We'll say OT, offset and type. This is kind of how we get struct fields. We're hand waving, but that's okay. If the type is a pointer, then what do? We emit an instruction to set the C register. So we'll say immediate. We'll say set the C register. And then we'll have the value of the variable WO, right? So this is like emitting actual instructions. If it's not a pointer, then we want to add WO plus equals the offset of the field. So the idea is that we accumulate this thing, we accumulate these offsets, but then every time we hit a pointer, we kind of commit that to an instruction. Except, hold on, that's still not quite right, because do we just throw it away? We just throw it away, don't we? Do we? No, that's still not quite right. What we need is wait. That's not right. That's not right at all. What we need is, so let's actually say we load. Yeah, so what we had, so we load this offset that we had, but then after we have that, we also need to emit a load word. Right, where we load whatever was at this address. Then in the C register, we can continue to add to it as we find additional things from WO. And if we don't hit, okay, so maybe this needs to be an add immediate. So we're just increasingly adding these offsets to the C register, or maybe it takes 2 registers. It's actually kind of tricky. That's actually a little bit trickier than I thought. So what? I'm going to start trying to write it. I think I've got enough to go on. So we will start with this working offset though, but this working offset will be whatever we have first. We want to look this up. We want to load the address of this. Load address 2. Load address 2? No, we want to match BV, yeah. So we can expect this, we can kind of unwrap it. And then we want to say, we want to get from the scope this thing. And then we can map the result into an error. So kind of similar to what we had before. We'll grab this. Okay, we'll simplify this so there's a little bit less repetitive typing. We take a ref. We want a stir slice, not an actual string. We'll bastardize this name head. Okay, this is good. We're matching. We're gonna match against this. God, I don't know how I should be formatting this. I don't know what the right thing to do is here. So this is gonna be a block variable. A local that exists in an offset and has a type. We want to start with the offset of this thing. We want to start here. This is the root of all future incremental dereferencing. Xlinks, hello, welcome. We are deep in struct land. This is more complicated than I expected. More complicated than I expected. Maybe I just want to think about offsets for now. I probably want to store this in a variable too. There's probably some utility to storing this in a variable, because I'm probably going to have to do this weird type match statement as well at some point. That looked way nicer on 2 lines. Okay. So basically I'm rewriting this. Everything below here is dead to me. If this is a local, we're going to get the offset. If this is an arg with an index, we need to get the arg offset. Oh, but even this offset is relative to the... it's not absolute, right? It's relative to the base pointer. So even then, we need to look this up. There's still this runtime lookup. So that's okay. So that's fine. This concept is okay. So what I want is to put... let's put this in a register. Let's say that the C register is going to get whatever this is. But I want to load the address. So assign from stack to arg, load local adder 2. Base pointer 0. Add the base pointer to the register and then add, yeah. So we have load local adder 2 and load arg adder 2. So these do what I want. Load local adder 2. And I think out, maybe out. Do I have an out? I do. Okay, so local adder 2. We're gonna get whatever we're writing out to. What else went here? The offset and the register. Am I gonna put it into register C? C is our beta register. Load arg adder 2 is gonna be the same thing. Cool. If it's a global, I don't really know what to do in that case. This is in block. usize type. So what is the usize in a global? Adder. It's just the address. So always we put out an instruction, we push unresolved well, actually, technically we can't just do this in one instruction, which is why we have a helper function called load adder 2. Oof, Fuster in chat. What is my favorite Vim motion? That is a question and a half. That is a really loaded question. I mean, DI is really cool, right? DI just feels very productive. I think DI, right? Or like CI, when you do a good CI, it's really, oh, mwah. It makes you feel very big brain. Okay, so these functions are load local adder 2, but then this is address 2. How are you going, Fuster? Are you still a big gamer? Register, yeah, okay. So register C register. We'll pretend that we support paging even though we don't. Block. What do we do if it's a const? Well, a const can't be a struct, so that's bad. A const cannot be a struct. So we probably want to say like, hey, return we want to say, I'm probably going to need a new error type for this as well. Or non-struct field reference, actually, that's perfect. Compiler error non-struct field reference. And that's going to be the head, name, the name of the field, and then the type of the field, which in this case is an int, I guess, because all consts are actually just ints. Excellent. Wonderful. I don't think it will like this, but let's see. I'm going to wrap this in braces because it looks nicer. Gaming sometimes not as much as it used to be. I know the feeling. Diabolical Rogue came out. I played it like 3 times, and I'm like, I'm going to play more. I'm going to play more, and then I just keep not doing it. I keep not doing it. I've been playing Splatoon with my girlfriend, and that takes up a lot of my gaming energy these days. Honestly though, Splatoon, pretty good game. Pretty good game. Getting pretty comfy with Rust by now. You learned Rust a while ago. Yeah, this is the thing. I had to quit my job to start my own passion project to actually properly learn Rust. I have actually talked to some recruiters, and I basically, like, I think 2 recruiters now have been like, oh, you know, I've been doing Rust, but I don't think there's any jobs. And they were like, well, I might have something, but then I never heard back about anything Rust from them. But I'm on a couple of people's lists now. They're like, this guy knows Rust, and I've gone to Rust meetups and stuff. So hopefully, maybe one day. Okay, so we've got the type of the variable. Now, this is probably worth checking before we do the offset, because if it's not a struct, then we have a problem. Also, this is eventually maybe going to happen, some of this in a loop. And then it's a crypto startup. Yeah, that's the only thing. I met a guy at a meetup who was working for a crypto exchange, and I was like, do you feel good about this? And he was kind of like, eh. And then I asked how much he earned, and he told me, and I understood why he worked for a crypto exchange. Yeah, I don't know. Everyone has a price. Everyone has a price. I know what mine is. Oh, it's really funny. You look at like jobs that are going and you're like, I don't want to work for Microsoft. And then you see how much they pay and you're like, do I want to work for Microsoft? Do I? If I go into the interview and I tell them that I rage quit Windows in 2011 and I only use Linux now, is that going to hurt my chances of getting hired? Would I take a job at ByteDance if they paid me? I don't even want to say. I would also have to move to Sydney, so that was a hard no. No amount of money to live in Sydney. That semicolon doesn't belong. Okay, so we have the type and we have a working offset in register C. This is important. Now, for every field we encounter, so now we have to loop through the fields. And this is, let's put a loop in. Let's assume we're doing this in a loop. So, actually, let's do a for loop. For field in fields, except it's the slice that goes like this because we've already taken the first one. And maybe we ref this, I'm not sure. I don't think we need to ref it. Sysadmin managing a Microsoft environment. Yeah, man. Are you still, you were at a place in the city, right? I think I remember where you were working. You were at the same place. I don't want to like dox you. To all of my rabid viewers. Same place. Yeah. I was actually looking at some jobs in that kind of sector because I was hoping to get something part-time to just, basically do that while I still mess around and write Rust and go to open mics, try and make music friends. But I don't know, I might take a full-time 6-month contract if they want me. Yeah, like completely different industry, different again to anything I've done before, but, pays good. And it would be good to get contracting experience if I want to be flexible. Yeah, my one Twitch TV subscriber isn't quite going to cut it in this economy for rent and stuff. But it would be fun to have the flexibility to still do this and try and grow an audience and, just like work on things that I'm passionate about. So for each field, we kind of need to do the same thing. We need to get the field. So it's like this part. It's like this part where we get it from the context. But instead of from the context, we're going to get it from the type. So again, I kind of did this down here where, yeah, I get the fields or I return an error. Well, or I panic. And panic is okay. I will accept panic as a valid outcome. So we get the fields of the struct. We get the fields. and we get the working offset, which is the address of the root of the struct, okay? So we have the fields of the struct, which is good. Head var. This needs to be called head var. Head var. Okay. So we have the fields of the struct, right? If it's a pointer to a struct, we just get the fields of the struct. We will need to know this at some point. But we don't... I should know, because we're starting with this offset, right? But if this is a pointer, then this offset is different. So what we actually need to have, before we do this, we need to check first. We need to say if var type is a pointer. If it's a pointer, we don't want this logic. Otherwise, we do want this logic. And I think I can else match. I think Rust will accept this. If var type is pointer, yeah. But yeah, I actually applied for some like sysadmin jobs, not Microsoft ones. Well, I did apply for some Microsoft ones, but I won't get them because I don't have the experience. But I literally went to seek.com and I looked for casual part-time and I typed Linux in the search box. And I think that's a solid strategy, to be honest. I think even though I don't have necessarily strict sysadmin experience, I think maybe for the right low-level job, my experience would be enough to get me in the door. Maybe. Nothing that would pay as well as what I can make programming, but, you know, literally just type Linux into the box. Okay, we have the fields of the struct. We have the type definition of the struct. If this is a pointer, then we need to dereference. Like, our working offset is whatever we dereference. Or not even dereference. What the working offset is the start of the pointer, because if we want field 2 that's at offset 2, we add 2 to the pointer. So all we load, we need to do, it's like this, but we need the actual value of the variable. So we're still gonna say, oh, I'm not matching anything here. Head var. I think it's called head var, right? Head var, yeah. Need to match something. I was concerned about else match without a curly brace, but you need to put something in the middle. We also, if this is true, we need to match head var, and it's going to be a very similar looking thing, but we need the actual address stored in the variable. We need the address stored in the variable. So we don't care about the offset or the type, unless it's a global. In which case we do exactly the same thing. I don't think we can have a struct value that is not a pointer that is also a global. I don't think a global can be a struct value. I don't know how we'd initialize that. So this probably is also invalid. Probably not valid or reachable. But it can't hurt to keep it around because conceptually it's the same. If it's a local, then we want to load the actual value of the local. And I have a helper function for that. Assign from stack to local. Do I have a helper for this? Maybe I don't. Let's jump into our expression. You wish you knew a compiled language. There's no better time to start learning than today. Just pick up some C. C is surprisingly unscary. There'll be road bumps if you're more used to like JavaScript and stuff. Learning to manage your own memory is scary. Like, I mean, if C is too scary, go learn Go. Go. That's probably better advice. Go learn Go. Go is cool. It's very, very powerful. It'll be more familiar. Garbage collector, makes stuff easy. Really good standard library. Just go write a web service in Go when you have some spare time. It's probably worth doing. You think I'd pick up sysadmin easily, levels to it? Yeah, exactly. Can't say the same for developers on Windows. No, Windows is like a whole other world of certification nightmares and stuff. A lot of the jobs say Cisco stuff specifically, and so every cover letter I've written, I'm like, I don't have Cisco certifications, but I would be prepared to do them if that was, you know, part of the deal. Right? I will do a Cisco certification, but only if I know there's a job at the end of it. I'm not doing that stuff willy-nilly. I'm not subjecting myself to that willy-nilly. Okay, so when we get a variable, what do? Okay, so this kind of sucks. This actually really sucks. So what I need to do is this, but with an extra step. I need to, if it's a local, And I should write a helper function for this as well. Maybe I should do that now. Maybe there's a case that I should do that right now, but I'm not. We load the address and then we push an instruction that dereferences that address. That's all we do. That's all we do, right? Because if you think about it, that's all the pointer is. It's an extra step, right? So we need the actual value stored in the variable, which is itself a memory address. C is so simple, it's hard to use. Exactly. No guardrails, nothing to help you. If you want to do something stupid, C will gladly let you. Okay, so all we need is an extra instruction here, and it's going to be a load word instruction because this is a pointer. Load word. And I think this is the op order. I need to double check. I need to double check every time. Yeah, it's really stupid. Basically, the format of this instruction, the order of the registers is a little inconsistent. That's a problem with all of my instructions in this ISA so far. I'm going to fix it at some point, but the longer I leave it, the more work it's going to be. Probably after structs, I'm going to go and do it properly. Great place to start. C will help you understand underlying data structures. Yes, yeah, exactly. You got to do it all, right? Once you've written a hash map in C, you're like, oh, that's how that works. You know, it's a really good experience. You could do that in Go as well, but it wouldn't quite be the same. Am I building my own VM? Yep, this is my programming language compiling to my VM. It's me all the way down. The VM is pretty cool. It works. You can go play with it on my website. It's a little bit, the website stuff's a little bit Spartan, but you know, it's fun. It's all a laugh. Okay, so same thing here. Get the pointer, load the actual value of the pointer into a register, and then load from there. Beautiful, beautiful. Local adder 2. Nice. And then this is the same thing. And then if it's a const, we still say, what the hell are you doing? This doesn't make any sense. You can't do this with a const. You can't have a const struct pointer. That just isn't a thing. It's not a thing. Not in my language anyway. Okay, this is really ugly, but we can work with this. So we get a working offset. Now this thing basically has to go inside of the loop. This thing really has to go inside the loop. We'll move it there once we see what happens. Once we see what happens. So for each field after this first field. And I think this first field is a little bit special. This first field's special because in the future we don't do this, right? We don't load the base. We only kind of do this for pointers after the base of our kind of struct dereference chain. Okay, so for each successive field, we need to work out. Oh, this is so tricky. This is so complicated. So we have the offset of a struct in the C register. So we need to get the type of it again. And then we need to get the fields again. So we got to do this. We're going to copy and paste it. Okay, so this is really dumb. We're going to reduce the copy and paste at some point, but not yet. Field var, we're going to have to grab this as well. This variable doesn't exist yet. Except it's actually not a var, it's just the field. We're just going to call it, no, we'll call it field. Actually, this isn't how we get it, is it? This is, we have to, field type equals something. We're going to put a hole here. We'll put a hole. This is something we have to fill in later. But the field type we can still get. We can still grab that. Okay, so we have the type of a field. This is good. Let's call this fields. Okay, we'll call it fields. This is a dumb name, but it's a workable name. Fields, right hand side. Fields. You never realized I was into this sort of thing when we were playing Quake. You've gone as far as writing a chip 8 interpreter. That's cool. That's really cool. Chip 8's a good spec. I like it a lot. And it's good practice just writing stuff like this. I literally have no idea what I'm doing. As much you could say I'm into stuff like this, but I really don't know what I'm doing. You know, I'm a back-end like application developer, and I'm dabbling in compilers with no real understanding of how to actually build a compiler. So I'm failing forward. If you can't tell, I don't really know what I'm doing right now, but we're making progress. We're making progress, and it's kind of fun. I think people are watching this and enjoying seeing someone with programming skills work through problems they have not anticipated. So I think there's some value in it, even if it's a bit rambly and slow. It would take a while to get there, but you know, sometimes it's the journey, not the destination, right? The programming language we get at the end of this is not particularly spectacular, but man, did we all learn a lot on the way there. So we have the field, and then we can get the offset of this. So this field, the field type is whatever we get in the, so let's go down here, let's go let mut current type. And this is called var type for some reason, because I copy pasted. This is a bad name. So field type is, and this is, okay. So this is gonna get messy because Rust does not necessarily like us doing this kind of mutable assignment. This might actually be a problem. So let's go struct fields, get field. Then we need to turn this into an error, and the error that we're going to turn it into is going to be a compiler error. No, it's not a non-struct field reference. It's a field does not exist. So we probably need that. Struct field does not exist. And we're gonna give the name of the type of the struct and the name of the field. Okay, struct field does not exist. I've gone for really verbose names. I think that's good. I think verbose names are good. Struct field does not exist, so it's field. We need a copy of it from toString, and then we also need dot clone. We're not turning that into a string, we're turning it into a clone of itself. Okay, so we have the type of this field in the struct. Indeed, we might be able to say that this is just current type, but this is messy. This is messy. Doing this reassignment in a loop, Rust might have some issues with. Let's put it in a different variable first. This might save me some headache later. Okay, so the fields of the fields we can get, and then we do this thing again, but it's going to be subtly different, I think. I think it's subtly different. The subtle difference is, if it's a struct, SF, field type. Oh, hold on. This is actually two things. Field offset and field type. And I think they're in that order. Actually, I think they're in the opposite order. Yeah, type then size, then offset. Okay, so this is good, this is good. So if this field, if the parent, no, we just add the offset. Whatever we do, we add the offset. Then if it's a pointer, we deref. Okay, this we can do. So out.push, we push an instruction. That instruction is going to be an add immediate. We're going to target register C, and we're going to add a new 7-bit number. I hope this field offset fits in 7 bits. Because we're adding it anyway, and if something goes wrong, we're just gonna unwrap it. We're gonna blow up if we can't do this. Okay, so because it doesn't matter if this is a pointer or not. We are getting this field from in the previous step we did the dereference, so the pointer bit doesn't matter right now. All we do is add the offset. Then then if, yeah, this is good, this is good. Okay, okay. We're getting it, we're getting it. If field type dot is pointer, right? If the field we just got the offset of is a pointer, then the next thing we need to dereference, but we don't dereference it if it's the last thing. So the last field has a special meaning. The last field has a very special meaning. So if how do we do this? Do I need to enumerate? Do I need... Maybe I need to do this. I'm going to have to duck out for one very quick second. I'll be back very shortly. I need to go check on my soup. Maybe give it a quick stir. I will be back momentarily. Alright, soup's coming together. Soup's coming together. But yeah, Fuster, it's really funny how many Quake people are into coding and stuff. I was chatting to Donna the other day. He's a programmer. I thought he was like 16, but I guess he was 16, you know, he was probably like 18 or 19 when Quake Champions came out. That was 7 years ago now, right? Like it's kind of crazy. QuakeCon 2017, that was the first one. Yeah, Fears hangs out in my Discord. He's been in my chat before. It's good. It's good. It's good to see people, familiar faces. Knight comes and hangs out in my chat sometimes. Oh, okay. So if this is a pointer, we just need to do a dereference, and that's very easy. It's very, very easy. All we say is, oh, but we need to check if it's the last one. And I not equal to fields len -1. So if it's not the last thing. Yeah. Donna was saying he'd made he'd made an anti-cheat like program, and he'd also made aimbots for programs, and I was like, oh, that's interesting. But he said not Quake. But you know, I think from an academic point of view, right? Like, how does it work? Like, can you? Which is cool. I respect people doing it academically, because that's how people develop good anti-cheats, right? You've got to have the ability to write an aimbot to understand how people do it. Yeah, it was interesting. It was interesting. It was also just good to wind him up about it. Okay, so if this isn't the last thing, then we have to dereference again. Actually, even if it is the last thing, right? No, but hold on. At the end of this, we're going to have an address to a thing. Then we're assigning to that address, because this is, for example, that's a bad example. In this case, right? So foo has an address which is on, you know, in our stack frame. Bar has an offset within that, so we add 2, or add 0 in fact. This is the first thing in the struct. If we say int x before this, then we would have to offset by 2 to get to bar. And then to get the field x, we add 0 again. And then we should be left with a memory address in the C register that we write the number 5 to. So that's what we should be doing. So what if this was a pointer to a bar instead? How does it change? Well, we get the offset of bar, we add 2 to wherever foo is in our stack frame, right? We add 2. And then we have a pointer to a bar. So we have to dereference that before we can then go on and add an offset to what is there. So that's what I'm doing right now. But if the last thing, right? So if bar has itself a pointer to a bar, and let's call that x as well, right? This is a memory address. We don't want to dereference it, because we want to assign 5 to the address of that address, right? What we would be saying here is the point, like x points to address 5 in memory, and there's a bar there. So yeah, so this is what I'm on the right track. You don't dereference if it's the last field. So we want a load word C load the word from address C into the C register in the 0 page. Everything's in the 0 page. We have paging memory. We're in theory going to be able to have long pointers in the future, but we're not there yet. We're not there yet. Okay, so Fuster, are you in my my dev Discord, my programming Discord? I should give you the colored role. I don't think you are. If you're in that Discord, let me know. I'll give you a yellow name because all the Quake boys get a yellow name. I'll link you right now. I'll link you right now. Oops. It's pretty quiet, but you know, we're building up a community. Some people share some cool stuff they're working on. It's nice. It's nice. You know, you gotta crawl before you can run. So what we end up with here, apart from the fact that we don't loop. So then what I need to do after this is say current type equals field type, and current fields equals struct fields equals fields. And the reason I'm putting this at the end is it'll hopefully be easier to see if any of the stuff accidentally borrows field type and type, because if any values that escape this loop depend on these variables, then doing this in a loop will blow up. It'll fail. It'll fail, which isn't good. So, does this work? Does this just work? Do we just try it? Do I build and see what happens? Well, once I get rid of all this, shit. Wait, did I add the offset? I added the offset. Then if it's a pointer, you deref. It's kind of perfect, right? It's kind of perfect. Did I go too far? If it's a pointer... No, this is what I was doing. Okay. Oh, but then we need to do this still at the end. So this can stay. I think all of this is valid. And this is good as well, actually. This is the most work I've done not on the stack. So that's good. We're going to load... Okay, no. So we don't do this. Pop value to write from stack. This we do need to do. So we pop from the stack into the B register. Because up here, I think... Did I not do this? I don't think I did it. I didn't do it. Okay, so I need to compile the expression. I need to do that first. The first thing I need to do is compile the expression and put it on the stack, because compiling the expression may mulch my C register. And it makes more sense to do this first. So we're gonna let compile expression. We need... What do we need? We need a few things. Context, scope, expression. Okay, so context, scope, mutable ref to a scope. I forgot to put a marker there again. That was silly. I was gonna put a marker there so I could jump back if this happened again. That's okay. That's okay. Cool. So this compiled expression puts an expression onto the stack. This is good news. This is good news for everyone. Because then down here, we just pop it from the stack. So we have C register has our address, B register has the thing where we're writing. We write it, we assign, we write a value. Beautiful, and then we build and everything works, first time. Okay, so else match, illegal. We have to indent it 1. That's okay, that's very, very workable. Would have maybe looked a little cleaner, but that's very workable. Oh yeah, and also this whole expression just needs a little semicolon. Kind of perfect. Okay, field. We don't have a variable called field because we have a variable called fields, plural. BV doesn't exist in the scope. That's because it's called head var. Offset not found in the scope. Why not? Why not? Because we, for some reason... Oh yeah, we still need the offset of the variable. Obviously. I thought because we were just loading the address, like we're treating it as a pointer, we didn't need this offset anymore. But we do. We do need the offset. We definitely need the offset. Always need the offset. Cool. Alright. And I should be going through my quick fix list, but there are enough things here that I just want to kind of keep. Wait, what is going on here? What is going on here? I just kind of want to keep recompiling because I suspect that the errors will be very naive, and also they will have knock-on effects to other things. Field type head var type. RHS type. Right value RHS type. Let's go type of. We need a context. We need a ref to a scope. I don't think it needs to be mutable, and we need the right hand side. Cool. Compile. I think it's called compile expression, right? Not compile expr. Because I like writing out names in full. That's good. That's good. Expected string found ref to a string. Yes. Of course, because I did the copy and everything. I just did it wrong. Offset. Expected U8 found type. Oh, the offset comes before the type. Okay. So I got the order wrong. This is going to happen quite a few times. Rust might have the most descriptive, specific, and detailed yet confusing compiler error messages of all time. For detailed yet confusing, well, actually no. You're right. I was gonna raise C++ templates as a contender for most confusing, but they're not very detailed. Their lack of specificity and detail is probably the problem. Rust errors are incredible. It means that as someone that doesn't know the language, I have been able to just completely make it up as I go along. It's stunning. It's stunning. I've never had another language experience like this. Go is pretty good. I found Go's errors to be pretty actionable, but yeah, Rust is on another level. Expected U8 found usize. Okay, so now we need to do this really silly casting. And this is not how you do this casting, right? This is not how you handle this. But for now, like, this is gonna be tech debt later, if not immediately. But these offsets, they can really only be 8-bit numbers because we have to add them to things. I don't know. It's definitely gonna bite me. Okay, load address 2. I forgot to give this an address. That's kind of hilarious. Unexpected argument. Load address 2. Huh. What does load address 2 return? Oh, it returns the thing. Okay, so we need to say out.extend. The compiler is really good once you know the language, the philosophy. I think even before you know the language, I found it useful, and I guess I'm not maybe an average programmer. Like, I've read a lot about Rust over the years. I have a lot of experience writing other code, and, you know, I've written Haskell, I've written other bits and bobs, but I think with all my background and my experience, I had the lingo to make sense of it. But I definitely understand people that find it a bit dense, a bit, you know, some of the concepts a bit harder, the people who fight the borrow checker. It is definitely not always obvious. Field in fields. What is this? This is a borrow Oh, yeah, okay. That's because we need to... I have this wrapper type for identifiers. They're not actually strings, they're identifiers. That's not very many errors. Okay, it was just waiting for another round of errors. That's okay. Working offset is never used. Oh yeah, that's because we don't actually return anything from this. Hey, I guess working offset is kind of redundant. That's really funny. That's really, really funny. You had a lot of fun and extreme confusion dealing with generics and trait bounds. Trait bounds, like, I like when the compiler's like, hey, just put plus something here, and you do it, and then the compiler's like, no, not like that. Sometimes they kind of bait you. Let me show you some generics. This was fun. right? Because I wrote my own parser combinator library, and so I wrote my own type, and it turns out you need like, because any is generic on 4 parameters, but like the actual struct is only generic, like the only field in the struct is generic on one of those parameters. There's 3 phantom parameters, so you need this field that doesn't take up any space, that has extra stuff. That was really fun. The compiler told me to do this, but it was still fun working out kind of exactly what it meant. But it did actually say, like, you need phantom data here, which was cool. Because it turns out that just one generic parameter referencing other ones isn't enough. The compiler isn't satisfied. The struct needs to have a field with those generic parameters. So you have to have this, like, fake type, which is kind of funny and confusing. Okay, so what was wrong here? Struct fields. Struct fields is not mutable. It should be, though, right? Because we try and assign to it later. We try to assign to it later. So that's concerning. That's very concerning. Yeah, here we go, here we go. Cannot assign to struct fields because it is borrowed. It's borrowed here and then later used here. So it's borrowed. Why is it borrowed here? What about this makes it a borrow? This is where it's going to get really messy, because loops in Rust have this problem where if something's borrowed in the first iteration of the loop, you can actually end up in a situation where a value is used at an earlier line number than the borrow actually occurs. Loops can get really, really messy. So we get something from here. Can we get this? Can we get this with a clone? Can we Rust map get and clone to avoid borrow? This is what I really need. I don't want to, time to dot clone. Seriously. Like, I think people are scared of clone. They're like, oh, well, I can't waste memory. But it's like, memory's pretty cheap. Sometimes just rolling with memory is okay. The problem is that I need to do it, I need to definitively copy. Like, if I'm not careful, these 2 variables will have the same lifetime as this entire block, so this assignment will never work. Now, one funny trick that I learned is this, where you can make a sub-block, and the borrow will only exist for as long as the block. So then maybe in here, maybe I can say let field type field offset. For one thing, the type is the only thing that is actually borrowed here. So I could probably say this is field type dot clone, and then maybe field offset, I think. Let's try this. Let's see. So I'm kind of tricking the compiler into having a smaller context in which these things are borrowed. I think. Or not even tricking, right? I'm just being explicit, like, hey, these things actually don't have to have the scope of the entire block. Always the semicolon at the end of your if expressions. Usize cannot be dereferenced. Oh yeah, but this isn't a reference now. That's cool. And I think that works. Current type equals, sure. Let's do that. Field type declared here. Oh, because it's, okay. So field type now, or current type, needs to be a clone. It needs to not be a ref. And that builds. So what happens if I test now? This is surely going to blow up in a whole bunch of weird ways. Indeed. Non-struct field reference. Pointer void. Okay, so this is actually in a different test. It's saying that the field out is not part of this struct. This struct that has fields pointer and len. So where does out come from? This is in our struct test file. This is struct in frame. Where the hell does the string out come from? Oh no, sorry, struct in frame. It's this one. Where does out come from? How do we get out? Dev Ninja, welcome. How are you going? How are you going today? How are you feeling about structs? Have you heard the good word about structs? Because I kind of hate them right now. We're gonna do a silly thing. We are gonna We're going to println. We're going to println and say assign deref. Wait, not deref. Sorry, that's the wrong statement. We're going to assign struct field. We're going to println, and this is going to show up in the output of any test that fails. Assign struct field. We're going to fields equals RHS. The right-hand side we can actually format as a string. The fields we can't. Okay, so now when we look at this test, we're gonna get something here. We're gonna see what's going on. And I wonder if fx. I wonder, where does out come from? Where does this string come from? How does this happen? Because what we should see is f.x. But we have this weird struct that appears to come from somewhere else. What does this even, like, what? Like, huh? Struct in frame, codegen 320. That's okay, 320, right? It's saying, hey, we can't assign this, and that makes sense. That's is it? No, hold on, what's it saying? It's saying field. Wait. Oh, this one panicked. Whoa. Then field set. Okay, this one fails. This one panicked. I misunderstood. Nested structs also blows up. It says bar isn't a known type. That's not great either. That's also not great. How am I going? I'm doing good. I had a really chill day. I saw a movie today, actually. I saw the movie Sting. the one with the really big spider. And it was okay. It was a movie that I saw. I know I liked it. If you like corny monster stuff, you'll probably enjoy it, even if it's not perfect. Okay, so we've got 3 different errors for 3 different tests, which isn't exactly fantastic. Oh, well, I mean, this we can't assign to a struct. Maybe. Let's see. Let's do that again and just see that these errors stay the same. Not to movies, coding better than everything. Wow. Sometimes you need to chill out, right? I do find that chill out activities that don't involve a screen can sometimes be good, but I don't know. I like a good movie. I like a good movie when I watch it with people. I think the company is always what makes it. So this is the right chain. This is the right chain. So we're getting the right stuff in, which is good. And I think nested... Yeah, this is also the right chain. So that's okay. That's okay when we say out.ptr. But we're trying to reference out. So we're trying to get out from this. That's not right. Here, we're trying to do something with x as an int on line 320. That's not right. So field types. Oh, of course, right? Of course. We only panic here. So we have different logic for everything except for the last field. But even then. Field type. So the type of the field, the type of the field only matters. The type of the field only matters. Fields. The type of the field only matters if there are more things. So fields. Okay, so we only do this. We only do this down here. So we're gonna put this at the bottom. We're gonna put this at the bottom, and we're gonna say, we're gonna say struct fields if I is not equal if I is less than fields.len minus 1. So if we're before the last element, then we update struct fields. Otherwise, we just don't care. It doesn't matter. The struct fields, we get the type of the next thing. And then if we try and get another field, it's going to blow up. So we do this. And I don't know why I commented this out. Non-struct field reference, except this is field.toString and this is field type.clone. And this is probably going to yell at me for some reason. Wait, that's the whole if. Okay, that I think is good. Field type move occurs. We move it here, but did you consider? What if I just borrow it? Except we don't want to clone, right? We don't want to clone. Now we have this problem where this, I don't know if I can clone this actually. I don't know if I can clone the whole hash map. This has box resolve t, so maybe I just put another thing here. Is the borrow checker happy? No. So we're gonna undo all of that. We're gonna undo all of that because that was ugly. You watch coding streams and videos to relax. So who else do you watch? I do enjoy watching Soding sometimes, but I haven't watched any of his stuff for a while. Just hard to find time to watch coding stuff when you're coding, you know. Okay, so current type equals, oh, hold on. Can I just do that? I forgot, we use field type below here, but so that means probably I don't have to clone here because that's the last time it's used. We can move there. Okay, that makes sense. That's what was going on there. I used to watch Strager. Yeah, Strager's raided me before. They're pretty cool. I enjoy Strager stuff. Soding is one. You watch German streamers. That makes sense if you speak German. Where's Soding from? Is Soding Russian? I can never tell. The like Eastern European accents blend together a little bit for me. I don't really have the ear to discern them. We're still trying to get out of that field, which is not good. Here we're trying to reference field x, which is an int, which isn't good. We should have stopped by now. So we've got, again, different issues, different errors. Non-struct field reference x as an int. So we don't want to keep going here. We don't want to keep going. Is that what I want? Do I need to stop one earlier? Maybe. Maybe that's good. Maybe that is... Yeah, I need to stop one earlier. Okay, that fixed some things. And then we just end up with a slightly wrong value here, but that's okay. What is 23124? Let's Python... Oops. Let's Python this up. Hex 23124. Was that it? 5A54. 23124. Is that... I did 24124, did I? 23124. 23124. Okay. 5A54. 5A54. Oof. Okay. So 5A54. Where can that number be coming from? It's really hard to trace what's actually going on in these tests. Thankfully, I actually log out every instruction that runs as part of it, which is surprisingly useful. So this is a test we would expect. So CB store word CB0, load word at MC1. So we want to find the point where we load the base of the stack. And I think this is where we do the offsets. Because then we store, we pop the, yeah, okay, so we push the constant to the stack. BP0C. So we get, oh yeah, we get the first, we get the base pointer, which should be also the address of the first local in the stack frame. We add 1 to it for some reason. That doesn't seem right. We add 2 to it, which might be right. I might have to do a VS here. Oh, except this is hold on. What I want to do is make a new buffer, and then I want to use R. R make T. Yeah, there we. No, doesn't that work? Is it because this goes to standard air, not standard out? Can I do this? Okay, there we go. Perfect. That does. Okay. I don't really know how to use colon R. That's okay. So This is where the money starts to happen. And if I look at this test, nested fields, right? So foo should be at this address. Why do we add 1? I'm not sure. This 2 is correct, right? We add 2 to get to field bar, and then we add another 0 to get here, and that's good. Then we pop, and we should store that word. Now we have to do it in reverse, right? So I have to do it in reverse. I don't know why we add 1. That doesn't feel right. That doesn't feel right at all. Now I can actually check this, right? In our context, we should... Can we see? Hello? Oh no, we don't get the locals anymore in our context. We used to get locals in our context. It's kind of annoying that we lost that. Actually, no, surely it's part of the context, right? User types, globals, functions. But a function, a block should have its locals, right? Block scope. Yeah, it has. It's part of the block scope, so it gets forgotten after we've compiled the function. That's really annoying. Oh, that's so annoying. Again, I'm going to do some debug printing. I'm going to do some debug printing in my code gen. So when we declare, when we declare a local with no body, we're just going to print ln after we get the, oh, this is really hard to read in a split, isn't it? Actually, no. When we call scope.declare, define a local, we're just gonna print this bad boy out. We're gonna print ln. At offset. And then, of course, a semicolon. Everyone's favorite character. So what do we see here? Local foo. It's a struct. And it's at offset 1. It shouldn't be at offset 1. That shouldn't be legal. That shouldn't be allowed. So why does this happen? Allocate local space. I have a sneaking suspicion why this happens. Local offset should start at 0, right? It's default. Local offset usize, the default will be 0. Allocate local space. So local offset, align. So somehow, if size is bigger than 1 and it's even, if size is bigger than 1 and it's not even, we need to offset by 1. So now this should work. It still doesn't give the right answer, but we should see the correct offset, which is at 0. So that is what we expect. That's good news. That's really good news. So now we see this extra redundant add immediate C0. It would be great, and maybe, maybe to not omit these, but maybe even to have a pass that goes through and finds no ops and erases them from existence. That might break some offsets. But I guess maybe if I do the right point of compilation, it would be okay. It would be nice to not have no ops in my code. It would save cycles. It would be efficient. It would be good. So we add 0, we add 2, we add 0. That should be fine. What is C here? I'm not totally sure. Let's jump into our test. Let's grab this out into a file and let's step through it in my program visualizer. Everyone's favorite part of the stream. Cool. And yeah, like this is basically my main tool for dealing with this. I still haven't written breakpoints. Still haven't done breakpoints. That's okay. Cargo run. We're gonna run my lang compiler. Excellent. Then we're gonna copy this. we are going to run our web server. Excellent. Let's paste this in, build it. Except, that's weird. Let's get rid of the stuff that we don't need. And that's very silly. Okay, now it builds. Now it builds properly. I might actually just reload the page and make sure that doesn't impact anything. Cool, so we're going to build this. And we're going to step. We're going to do everyone's favorite thing. We're going to step. So we're in our main function. We add 4 to the stack to make room for the struct. We're going to follow this through. We're going to follow this along with the code. Because this struct has size 4, it has 2 fields. This is beautiful. It has a field of size 2, and then it has a field which is a struct, which has size 2. So we need to make room in our stack frame for this data. Beautiful, beautiful. We load the value 5 here, and now we're going to set up the address relative to the stack. So this should be 16374. That's what we expect to eventually be in the C register. So we start with 13672. We get 16374, and then we write to that address. That is correct. That is perfectly correct. Then we're going to do this again. Now, for some reason here, we have this extra load word, and that's not correct. That's not correct. This is dereferencing garbage. Okay, that wasn't right. That wasn't the button I meant to hit. Okay, but what we're going to see is... CC0. We load whatever's in that address. But that's not right, because we're going to load word here again. So we load whatever was at memory address 2, and that blows up. So something went wrong. Something went wrong. And it's in our code gen, and it's when we expression... It's when we... literal car deref address of... It's when we... It's called field deref for some reason. It's a really silly name. Okay, so we do this stack pop add immediate load word. If it's a struct, if it's not a struct, what does this mean? What does this mean? I think I want to say if field is a pointer, then we load word, right? Is that right? Field table says fields. If the field is a pointer, let's just try that. Let's see if it fixes our problems. No, but it gives us a different answer. 4098. Okay, hold on. 4098. Wait, no, is that backwards? Hex 4098. What's this? 1002. See, that's interesting. That's really interesting. Oh, because that's a different test. That test has ended up... So this is the address we wanted to write in that test instead of the value. So what test is that? Struct. That's here. When we say return out, I think we're returning the wrong... Oh no, sorry, yeah, when we return y.len, we're returning the offset of the thing. So this is the right address, but the value of the expression is wrong. We're dereferencing it at the wrong spot. Dereferencing it at the wrong spot. y.len. So what happens? So y. So we compile the expression, that gets pushed to the stack. Beautiful. We get the type of the left-hand side. The type of the left-hand side is this recursive thing that happens, right? So in this case, the type of the left-hand side is type array. It's this struct. So it's a struct with 2 fields. Okay. fields. So we're getting a field. We're getting the field y from this struct. Type struct, type clone. If it's a pointer, blah, blah, blah. So we get the fields. We get the struct fields, or we return an error. Beautiful, beautiful. Then we try and get the field. In this case, .y, it is the left-hand side. So the type of the left-hand side should be a pointer. So actually, what this is if ty is a pointer. Closer and closer and closer. That's good. That's good news. Also, what was the error here? Field type is unused. The type of the field is unused. Now that feels wrong as well. That feels wrong as well, but I don't know if it is. I don't know if it is. If the thing... So we get offset. We add the offset. So if the thing on the left-hand side, we want an offset from it, then we want to dereference it if it's a pointer. What if it's not a pointer? Then do we need to dereference it again? Because this is recursive, it's hard. Well, it's not recursive, is it? Is it? Where does the rest of it come from? The left-hand side. Okay. This is good. The right-hand side is now looking... the left-hand side is now looking really good. The right-hand side now has a problem. Okay? This wasn't what I expected. And the problem is in the fact that I basically have to pick, does value work or does pointer work? I'm unfortunately going to have to leave it there again with structs still unresolved. I would really like to not leave it there with structs unresolved, but that's okay. That's okay. Actually, hold on. Before I come back to chat, I want to check. I want to see. Can I check something off of my list? Can I check something off of my list? Nested structs. I think they kind of work. Size of didn't get to it. Offset of didn't get to it. Assign. This we actually kind of broke. Oh, no, wait, no, sorry. This we did, but we kind of regression. We regress something. Regression, x equals foo dot bar. This is now broken. So, all in all, some stuff happened. This was definitely a stream. We achieved some things. We moved forward, we moved backwards. Some stuff definitely happened. Let's raid someone. Let's find someone doing some cool compiler stuff and throw them a raid. This person has a new operating system set up. Slowly developing a creature collecting game. That sounds fun. Bad new retro programming with JPython. Ooh, who's a good streamer? Foster, thanks for stopping by. I always love to see Quake people come in and hanging out. Let me know if you're in the CBD anytime and you want to like grab lunch or something. You know, I'm around. I'm unemployed. I need to, if you have any good streams to raid, let me know. Always love to find someone new and different to throw some people onto. Yeah, I hear that Tom Marks Talks Code guy is pretty good. I hear they're okay. This stream is shady. Card shaders. I mean, that sounds fun. That sounds fun. No one comes to mind. That's all right. That's all right. Filter by tag. Is anyone on the compiler tag? Literally no one is streaming under the compiler tag right now. Let's just find a cool game dev channel. Kuviman is live again. Oh, but he has so many viewers. I've only got like he's exceeded the viewer count where I'm comfortable rating. All right, I don't want to do one of these like silly little raids. Let's four viewers. They've been streaming for an hour. Game jam. Let's throw it over to Crude Oil. Let's see what they're doing. It's Godot. I like a Godot stream. It looks like they've got an ironic literal PNG in the corner of their stream that like it's not animated. It doesn't do face tracking. They've got a nice little joke about it. All right, let's throw some viewers over there. Thanks everyone for stopping by. It's been fun. I've enjoyed it. We're gonna do structs one day. It's gonna happen, and let's do a fun raid. See you all next time. Bye.